Stop short of the goal.
Dang it.
All right, we're going. Hey, where are my physics people that done vectors? Oh, okay. All right, so this should be nice for you. Did you guys add them on paper? Do it on paper or geometrically? All right, so you might be a little bit ahead. We'll probably do things pretty similarly. We're going to represent them geometrically, then we're going to talk about them algebraically. A little bit of terminology here. Okay, it's a vector with, it's a quantity with magnitude and direction. It's also a superhero, or no, a super villain. So, where'd it go? My link is gone. That's disappointing. Daggone it. Where was it at? Fictional? It's not fictional. Let's see here. Maybe. Here we go. We'll have that the whole time.
Yeah, it's important. We don't get to watch this video.
Well, shoot, we'll have to bring vector back later. Daggone it.
Oh, yeah.
Awesome.
Daggone it. All right, well, back to vectors. Quantity with magnitude and direction. Talk about the initial point, and then you talk about the terminal point. You have to have an arrow on it. Okay, it indicates like movement or force, and the length of it is important as well. So you talk about, like I said, the initial point, which we can refer to as the tail, or the terminal point, which is the head. Let's see here. All right, denoting vectors. You can talk about them with italicized letters with arrow shapes over them. So like here, you got A, or capitalized letters, which indicate like the first point, the starting point, initial point, and then you get the terminal point with an arrow over that. The arrow does not indicate what direction it's going, okay? So if I have a vector here, and then this is C, this is D, you would still label it CD with that vector, that arrow going to the right. That's just a generic way to label them. Does not indicate the direction of the arrow, just says it's a vector. Also, you could not label this, or you would not want to label this DC, because the first letter indicates where it's starting from. Okay, so you would not do that. Make sure that would be labeled CD. Like same thing here. You got your initial point, you got your terminal point. You need to make sure that tells you where it's starting, where it's ending. Okay, for that. So that's just with the letters or with the beginning point, ending point. All right, so a bunch of little things here. Magnitude, think of it as this is the length. Okay, that is one way to think about that. Now, you should on your notes, like right above the middle there, there should be two lines to fill in here. So that's you would read this as the magnitude of U or the magnitude of vector PQ. Okay. Equal vectors. The only way two vectors can be the same is they must have the same length and the same direction. Okay, so you got vector U there, and vector V is the same. It's got to be exact same length. It's got to be going the exact same direction. Okay, it can't be going any other direction. All right, what about opposite vectors? Okay, they're going to have same length, but opposite direction. And what's that gonna look like? So here's U, negative U. Okay, going the opposite way for that. And then you got scalar multiples. So here's U. If you want to think about 2U, you just double its length, same direction. Now you wouldn't draw it with two separate vectors, but that's just giving you a reference. And then negative 3U would have to be going in the opposite direction. It would have to be 3 times as long as your initial U vector. Okay. All right. We're down in the front, right? All right, flip it over on the back, or not the back, flip it over to the next page. Now, how do we add vectors? If you guys add vectors on a grid, remember? No? Okay, so we're at least gonna go through that, just kind of give you a geometric idea how to do this. Okay. All right, so you're adding vectors. Go ahead and you're gonna do, I think there's 3 of them that go in this, that first big grid area, and then there'll be one that goes in that where it says parallelogram method, one goes down below there. So be careful on how, don't like slap this in the middle, put this up above. But for all these problems, U is going to be this vector, V is going to be this vector, and W is going to be this vector. And we're going to add those together. And so you can think about it, the length, it goes 4 boxes up, 2 over, and this one's 2 boxes down, 2 over, and then W is just 4 to the right. So those will all be the same. Now here's how you add vectors. You draw the first one, the U, and I'm going to cheat a little bit here. And so there's U. You want to start from the terminal point of the first vector. So wherever that arrow is, that's where you draw the second one. And so we're going to draw V from here. Okay. The answer, go from the beginning of the first one to the end of the second one. Okay. The beginning of the first one to the end of the second one. So my answer, U plus V, will be this vector right there. Okay, so that is U, vector U plus vector V. Okay, vector U plus vector V. All right, first question here is U plus V equal to V plus U. Okay. Now in regular math, adding numbers, yes. Okay, 2 plus 3 is the same as 3 plus 2. 5 plus 3 is the same as 3 plus 5. All right, take a look at vectors. It should look different because you're going to start with V. So if I start with V, that's my first vector. From the terminal point of there, I'm going to draw U. And hold on. And go from your first initial point to your terminal point, that right there. Now, it might not be obvious to you, but if you take a look from the first point to the last point, it goes up 2 blocks and goes over 4. Now, I might not be exactly the same just because of a little human error, but that's pretty good. There we go. But yes, U plus V is the same plus V plus U, so it doesn't matter what order you go. So yes, that is true. Oh, that's a bad Y. Yes. All right, so what do you think U plus V plus W is going to look like? U plus V plus W. So take vector U, draw it out. At the end of that, draw vector V. At the end of that, draw vector W. And then connect from the first to the last. And I'm just going to do it from here. So U, up 4 over 2, V, down 2, W, 1, 2, 3, 4. And then connect first to last. Okay. And you have to put an arrow on your answer. Okay. Now I got mine automatically, but make sure you do put an arrow on there. You can't put an arrow both ends. It's only move in one direction. So wherever you start at, that's your initial point, and then wherever you end at, that's your terminal point, and it has to be an arrow, because you got to think of it like if something's moving across it, it goes up, down, over, but if you go straight through there, you got that arrow. Now you can also switch the order. Take a look here. What does V plus W, I think is how I want to do it, plus W. It's got to be the same, but I want to just show you. V, where's that at? That's going to go down here, and then U goes up over here, and then W goes here. Now think about here. What's the final answer? It's okay to go through one of my lines. Okay, that is okay. All right, that doesn't matter. Sometimes people see that like, well, that can't be right. And if you look at it, it's got to be the same. That's a little bit of an illusion here that if it looks different, but if you take a look, it is going to be the same. Okay, so that doesn't matter. So no matter which way you do it, you still got to get the same answer. All right, let's take a look at one more in that little section. 2u minus 3v. Before you start drawing it, think about how it will be set up. Because if you just start drawing it, you might end up running out of room, or your thing might go off the page. You're going to run into something below it or above it. So 2u, think about that, minus 3v. Well, we haven't done subtraction yet, but here's what I want you to think about this. Just like before, 2u minus, we can write that as plus negative 3v. So that is the opposite vector. So it doesn't go in the same direction. It's going to go the opposite direction. Okay. All right, so now think, where do you need to start so that you don't like run out of room, or you don't run into anything else? Because here's what's going to happen. And let me just draw, I'm just throwing this out there, and this isn't accurate. 2u will go up this direction, right? But which way is negative 3v going to go? It's going to go that way. So you make sure you give yourself enough room for that. That was pretty close. All right, so 2u. I'm going to kind of start kind of in the middle and kind of as low as I can. So 1, 2, that's 2u. And I might run out of room here. Negative 3v. So for each v, you go up 2 over 2, up 2 over 2, up 2 over 2. So it should be like that. And then my final answer, all the way up. And then that gives me, make sure you got an arrow on it. Make sure you got an arrow on it, because that tells you where the direction is starting from and going to. Okay. So that's just adding and subtracting vectors. Subtracting vectors is adding the opposite. Just make it the opposite vector going the opposite direction. All right, questions on any of that? Okay, now at the bottom, what it says, the parallelogram method. We're going to do something we already know. We already know u plus v. What you want to do when you do the parallelogram method, start them both at the same point. Okay, so just pick a point and do this in that bottom piece there. And let's see here. And from here, draw u, and then draw v. Okay, both starting from that same point. Now make a parallelogram. Make a parallelogram with that. All right, so now with that parallelogram, I'm just going to copy and make these my other side, clone there. I'm gonna put it right there, and then clone here, and put it over there. So I got a parallelogram. The answer, okay, will be from your initial point okay? Whoops, hold on. Initial point. And you go along the diagonal. Okay, so you can make a diagonal. So it's going to go from your initial point to where the opposite diagonal is. Because you got to be careful because you got two diagonals. They're not the same. They are not the same. And so it would be that one. Put an arrow. Put an arrow on here. And really all of this is not part of your answer. Your answer is just the blue vector. Okay, so if you redrew it over here, I mean, that's equivalent to the answer. I mean, all that just helps you generate that answer. Let me go backwards. Really, just think about this. This is really no different. If I would take that, slide it here, it's still the diagonal. I just didn't draw the whole parallelogram. Okay, it still goes through there. We just didn't have those two sides initially. So, whoops. Oh, no. There we go. And then here. For that. Now, sometimes this is a better, because those of you from physics, you're going to know when you deal with forces, there are going to be two forces acting on one object. So it's a little bit easier to draw it or to kind of visualize it coming from right here. Okay.
Is the other diagonal u minus v?
I think that's the case there. U minus v. So that would be u, and then I'm trying to think there. And that v would go the opposite way. Yes, it looks like it's going to be u minus v. So that other vector is going to be, like he just said, the u minus v as well. All right, flip it over. Now you need to understand geometrically, but 9 times out of 10, you want things algebraically because it's just easier to work with. You don't want to have to draw this out every time. Drawing it out kind of gives you a good visual aid. And if you draw it accurately, it can give you the answer. But then if you're a little off on your drawing, it's going to be incorrect. So we're going to talk about vectors algebraically. And there's a couple of different ways to talk about them. Now, on the top of your paper, I got it worded a little bit different here. So a vector is called a position vector if the initial point is at the origin. So 0, 0. So if it is at the origin, that is it. And here's what this means. So V is 6, 5. Now look at the notation. That's not a parentheses, it's not a bracket. That represents a vector. Okay, that's different. It's not an ordered pair. This says I have a vector starting at 0, 0 and ending at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So draw that vector. That would be V. Okay. Well, the magnitude of V is the length of V, and if you look at it, it starts at 0, 0 and ends at 6, 5. All you got to do is drop a perpendicular down. You make a right triangle. You don't have to go through all that because you're just going to do V1 plus V2 squared. So the magnitude of V is equal to the square root of 6 squared plus 5 squared. And so the magnitude of V is going to be the square root 61. Square root of 61, you can leave it like that. That's fine. Square root of 61. All right, so it starts at 0, 0, ends at whatever those two values are. Now, take a look at W. Go ahead and fill in that as 5, negative 2. Find the magnitude for W. And then I would draw it on here as well. So W, just for a visual. 1, 2, 3, 4, 5. Negative 2. And let's see here. Magnitude of W is 5 squared plus, make sure the negative 2 squared becomes positive, square root of 29. A square root of 29. Okay, now not every vector starts at 0, 0. But what we want that to happen, because that's nice. Because then to find the magnitude, all you have to do is take, 6 squared plus 5 squared, take the square root of it. But if you have a vector, over here, then it just gets a little bit messier. So what we want to do is take any vector and make it a position vector. We want to slide it over. We want to move it over. So you got this vector here. I know that's not on your paper, but just take a look. Q1 is 1, 4, P is 4, negative 2. So this is the vector PQ. If this is a position vector, all I got to do is take this and slide it to here. And so what does PQ now become? PQ as a position vector is, what is that point? Negative 3, positive 6, okay? So it's a lot easier to talk about that as a position vector as opposed to here. Well, how do I take this and convert it to a position vector? Okay, the vector PQ with initial point P and terminal point Q is equal to this position vector. I think on your paper you don't have V. What do you have? PQ there? That should say PQ equals. So PQ equals x2 minus x1, comma y2 minus y1. Terminal point minus initial point. Terminal point minus initial point. And so if you take a look here, hold on here. What do I got? My terminal point is the end point. So if I take 1 minus 4, that is negative 3, where you ended minus the initial point. And if I take 4 minus negative 2, I get 6. So that's all you're going to do there. All right, take a look at that one below you, or below that one. They give you the initial point. They give you the terminal point. Give me the position vector. What's that going to be? Okay, where it says let V be a vector with initial point negative 5, 4, and terminal point negative 2, negative 2, write V as a position vector. All right, so think about that. Terminal point minus initial point. All right, Cole DeLuca, what do you got?
3, negative 6.
3, negative 6. Anybody got anything else? We're all good? 3, negative 6. All right, so here's this position vector. Or here's P is negative 5, 4, Q is negative 2, negative 2, and it's a lot easier. That didn't work. Hold on. If you take that and if you just slide it there, then it's obviously easy to see if he's correct, 3, negative 6. But algebraically, if you just take negative 2 minus negative 5, you get positive 3. And if you take negative 2 minus 4, we get negative 6. So that would be that vector. All right, we're going to kind of spread this out over the next 3 days. Vectors, there's a lot. They only come put in one section, so plus with spring break, we're just going to kind of chunk it up a little bit. So you should have a little bit of time in there. Well, obviously, you have some time in there. And do this on graph paper because you got to draw them out. And if you don't have graph paper, I know somebody that does. What do I do with it? All right, I got it back here. If you need graph paper, I can provide.
No.
Or you go to graphpaper.com.
No.
Yeah, good.
So,
Anybody need anything here?
Yes.
Okay. Everybody here good?
Huh?
Emily?
No, we're doing homework.
Yeah.
like seeing brown paper because I feel too hard to write every single letter. And I'm like, I can't do it. Like, I don't know. I know, like, I can't, because then I don't want to make the letters overlap with the lines and like. I just don't know. They're not